Good morning, everyone. My name is Bùi Minh Quang. I am a student at the class of Technical Writing and Presentation here at Hanoi University of Science and Technology. Today, I am incredibly excited to share my vision on the topic What is a control and automation engineer like in 2030? Or, you may say, kỹ sư điều khiển và tự động hóa là một người như thế nào tại năm 2030? In this, in this presentation, I will be covering 7 chapters. The first one is the 2030 industrial ecosystem. The second is diverse application fields and industry verticals. The third is core professional competencies, the synergy of hardware, software, and smart data. The fourth is market dynamics, job opportunities, global mobility, compensation, and battle for position. The fifth one is academic foundations and technical pedagogy. The sixth one is the pre-2030 strategic roadmap and countermeasures to critical challenges. The final chapter is the conclusion. To kick things off, let's paint a clean picture of the world we will be stepping into. Let's look at the industrial ecosystem in 2030. When we talk about 2030, we are moving past the theoretical talk of Industry 4.0 and stepping right into hyperautomation. We are looking at cyber-physical systems, the artificial intelligence of things, and the centralized edge computing. Because of this, the classic image of the automation engineer, someone who just sits in a factory adjusting basic PLC ladder logic or rewiring isolated panels, is officially a thing of the past. By 2030, we have to become cross-disciplinary architects. We need the technical agility to handle heavy electromechanical hardware on the plant floor while simultaneously managing cloud networks and data flows in a digital environment. So, as system architects, where do we actually deploy these skills? The answer is that automation is expanding into some incredibly dynamic industry verticals. In 2030, our expertise applies to three major pillars. First, smart manufacturing and industrial maintenance. Think of major corporations like Bosch Vietnam or Westlake Global compounds. Instead of traditional reactive troubleshooting, we use digital twins, live virtual replicas of the factory floor. We analyze real-time data streams to predict and prevent machine failures before they even happen. Second, we have the semiconductor and hardware design sectors. Building on the steps of companies like Renesas and Intel, here engineers use AI-driven tools to automate hardware verification and run complex microchip design pipelines. Finally, there's green infrastructure, similar to the system run by Cobell Eco Solutions. Automation engineers are now designing smart instrumentation networks to control large-scale water treatment and renewable energy grids to meet modern sustainability targets. Okay, so looking at this in diverse fields, from microchips to massive water plants, you might wonder, what does it take to master all of this? Let's dive into our core professional competencies. To deliver value in 2030, our toolkit relies on three essential pillars. First, advanced hardware and circuit synthesis. We still need a rock-solid understanding of the physical world. This means handling instrumentation control, fluid power systems, and using CAD suites like AutoCAD or Creo to design highly accurate physical systems. Number two, cross-platform software engineering. This is where the magic happens. Following the standards of companies like Panasonic Appliances, we bridge the traditional PLC frameworks with embedded C or C++ coding and cloud architects. We use agile DevOps workflows to deploy code straight to edge nodes on production lines. The third one is quality systems and risk mitigations. In high volume manufacturing, unexpected downtime is incredibly costly. That's why we must meet industry standard quality frameworks like FMEA, failure mode and effects analysis, control plans, and statistical process control or SPC to catch structural rescues early. Okay, processing these technical skills is fantastic, but how do they translate into the real world? Let's take a realistic look at the job market and career dynamics inside Vietnam. While Vietnam is divided into six distinct economic regions, my analysis focused primarily on two hubs, the Northern Tech Corridor and the Southern Economic Zones. This choice is influenced by the geographical distribution of major automation employers in our reference. The career opportunities are immense, but let's be completely real. It is a highly competitive battlefield. Top-tier companies maintain a high entry barrier. Entering a premier R&D hub like Renaissance, for example, requires passing a rigorous technical training program combined with a strict 2-year post-training commitment. The workplace demands are immense, but the rewards match the effort. Panasonic appliances offer fantastic performances bonuses, full salary during probation, and excellent corporate transit networks. Working with giants like Intel gives you elite professional exposure, transforming you into a global expert in tech transfer and predictive engineering. Knowing how high the industry sets the bar, how do we prepare ourselves, or specifically me? The journey starts with the academic foundation I received right here at HUST. This is exactly where C at HUST comes into play. HUST curriculum is specifically designed to break down academic silos by blending mechanical design, electrical infrastructure, and computer science into one unified pathway. First, advanced electronic and electrical engineering learning, high voltage and low voltage distribution along smart grid integration. Number two is industrial automation networks, gaining deep hands-on experience with multi-brand PLC design, especially modern Siemens and Schneider architectures, and industrial protocols like Profinet and Modbus. The third one is embedded systems and VLSD design, writing clear code in C or C++ for microcontrollers and using hardware description languages like Verilog to program FPGA prototypes. HUST gives an incredible toolkit. However, a great toolkit still requires a personalized long-term strategy to successfully transition from the university lab to the active factory floor. Here is my strategic roadmap. To ensure I hit mid-level readiness by 2030, I mapped out a clear phase strategy. Phase 1 from 2022 to 2024 focus on mastering advanced mathematics, core electrical tracks at Hust, and building professional English fluency. Phase 2 from 24 to 26 centered on mastering CAD suites like AutoCAD and Creo, embedded coding, and specialized chip design tools. Phase 3 from 26 to 28, moving in to factory immersion by targeting graduate engineering tracks at many corporations to learn real-world FMEA and quality control. Finally, Phase 4 until now, from 2028 to 2030, cultivating senior expertise, earning official state-vetted electrical design certificates, and learning project management from senior site supervisor. Of course, we all face major roadblocks: information overload, technology gaps, language barriers, and expensive software. To overcome this, I highly recommend four practical measures. First, we use selective microlearning. Don't try to memorize an entire software library. Focus deeply on the exact protocols or functions needed for your current project. Second, leverage your academic and corporate alliances. Align your graduation thesis with a real company to get free access to the advanced PLC and proprietary software. Furthermore, academic institutions and students should focus on technical communication programs to bridge the gap between basics, fluency, and the documentation standards required by global enterprises. Finally, maximize open source alternatives like KiCad or FreeCAD to practice complex configurations without a massive budget. To wrap things up, in the year 2030, the role of control automation engineer is no longer confined to a single isolated silo. We are evolving into dynamic, cross-disciplinary system architects who hold the keys to both worlds. Successfully bridging heavy electromechanical hardware on the factory floor with advanced cloud software is a digital space. Yes, the market demands exceptional national technical skills. The corporate pressure will be real. The hours can be long, and the competition in Vietnam's tech hubs is going to be fierce. But as we have looked at today, we aren't walking into this unprepared. By combining the powerful academic foundation we received right here at Hust with a clear chronological roadmap, project-based microlearning, and active corporate alliances, we can confidently turn these intense industrial challenges into massive career opportunities. Ultimately, the future of automation isn't just about making machines run faster. It's about making entire systems smarter, more efficient, and more sustainable. And as engineers, we are uniquely positioned not just to adapt to this 2030 landscape, but to actively lead it on a global scale. Let's embrace the pressure, execute our plans, and build the future. Thank you everyone for listening to my presentation, and I hope you have a great morning, great evening, great night. Thank you very much.